Another pretty easy one, but not as intuitive, is this transposition. So in this case, we have if P then Q, we can flip the antecedent and the consequent and add negations, and that we get a logically equivalent statement. So if the statement, if it's raining, then it's cloudy, is logically equivalent with if it's not cloudy, then it's not raining. And again, that kind of tracks our intuition of necessary sufficiency involved in conditionals, which I don't want you to get too caught up on, because again, we're in logic right now. We're doing pure syntax. So we don't know whether P and Q are connected with some kind of sufficiency condition or some kind of necessary condition. But that's the way we treat conditionals in ordinary language most of the time. So we're able to, if we negate that consequent, negate that antecedent, and flip them, we're going to get a logically equivalent statement. So let me do tautology first. So if you guys remember what a tautology is, it's just a statement in which the main operator is always true. So it's never going to be the case that it's false. And in this case, if we have a P, we can do P or P, because that's always going to be true. If P is true, P or P is going to be true, right? For a disjunct to be true, you just need one of the disjuncts to be true. And if P is one of the disjuncts and we know that P is true, then obviously P or P, both disjuncts are going to be true. And that's why it also works with a conjunction. So if we get P, we can do P and P. Now you might be thinking, when are you going to possibly need that rule when you're doing proofs? But you might end up working with the statement, and then all of a sudden you get a nice maybe like R and S, therefore P or P. You can just take that P or P away and put P. So you only have P left. So tautology is pretty easy to work with, but now let's go over some of these more confusing ones. So let me start with exportation. We have in parentheses as our antecedent and Q, then R, and R is our consequent. This one, we can change the parentheses to go around Q, if Q, then R, and that when the parenthesis changes from being around the conjunction as an antecedent to this consequence of Q, then R, that conjunction changes to a conditional. So what's an example? If it is raining and it is flooding, then we won't go to the park. So this one's saying if it is raining, then if it is flooding, then we won't go to the park. And those have exact same truth values on the truth table. Let's look at this first part, P and Q then R. The only way that's going to be false is if this antecedent is true and that consequent is false. But if we have this as a line, then we know that P and Q is true and R is not false. So if we know that, then when we change this into this two conjunctions or two conditionals, this is only going to be false if P is true and if Q then R is false. But we know that P and Q is true, then R is going to be true. So P is true, then Q is going to be true, and if Q is true, then R is going to be true. And again, this also works the other way. So if you get if P, then if Q, then R, you can get P and Q, then R. Now let's do material implication. So we have if P, then Q. And again, if P, then Q is true, then P is true, Q must be true. But if P is false, then Q could be true, could be false. So this disjunction, not P or Q, if not P is true, then P is false over here. But if P is false over here, then this conditional is still going to be true because it doesn't matter if P is false. Q is going to be true or false. It doesn't matter. And if Q is true over here, then we know that P has to be true too because it's the consequence of this conditional. So a lot of these I mean, like if I was in class, I might have written out the truth tables just to show you that they're going to have identical truth values. But a lot of it's just understanding that the truth functions of the conditional and truth functions of the disjunction in order to see that, yeah, if P and true is true, if P then Q is true, then not P or Q is going to be true as well. Either not P is true or Q is true. If P then Q is true. Okay, so this last one, material equivalence, we did cover this first one. So this is P triple bar Q, which is equivalent to if P then Q and if Q then P, right? So it's a triple bar is a conjunction of two conditionals where one is the antecedent consequent and then the other one they flip. So the consequent becomes the antecedent becomes the consequent. But the second part of a material equivalence is this bottom section here, which is, again, P triple bar Q is logically equivalent to P and Q or not P and not Q. So how does that work? If you remember the triple bar truth table, you remember that P triple bar Q is true when both P and Q are true, or when both P and Q are false. So it was that top row of the truth table and it was that bottom row of the truth table. So a triple bar is only false when one is true and the other is false, or when the other is true and the first is false. And that's what this disjunction is representing. These truth functions of the triple bar. So we have P and Q, which is that first row. If they're true, then the triple bar is true. Or if not P and not Q is true, which is that last row of the triple bar truth table. If that's true, if not P and not Q is true, then P triple bar Q is going to be true as well. So that's what this disjunction is representing. Okay. So again, when you do your tests, when you do your quizzes, you'll have it'll be open note, right? So you can pull up this chart and you can like start to see, all right, this is when I can use this replacement rule, this is when I can't, or I need a P, but all I have is a not P, but hey, look, I can use this replacement rule and do it. All right, so now I'm going to go over this example. So this is going to have all kinds of replacement rules in it. Okay, so we're starting with if P, then if B, then not P. Now, you might be thinking, okay, so how do I even start this again? I'm not even sure how to start this. Let's look. We need if P, then not B. And we have if P, but we don't have not B anywhere. So how am I going to get not B? Well, when I get problems like this, I usually just start doing some rules. Now, some of our implication rules, you only need to cite one line. So like simplification, where we get a conjunction and we just pull out one conjunct, you're just citing one line, just a conjunction. But a lot of the implication rules, especially like the ones involving conditionals, you need to use more than one line. So like modus tollens, you need at least 2 lines. Modus ponens, you need 2 lines in order to use it. You can't apply it to 1 line. And in fact, you can't apply those to 3 lines either. You can only apply that to 2 lines. Modus tollens, modus ponens. Hypothetical syllogism, you need 2 conditionals you're appealing to. So I'm starting off with just 1 line. So I already know, like, all right, and this line is a conditional, it's not a conjunction. So I'm all right, like maybe I can do like addition. So I can make if P, then if B, then not P. But making this into a disjunction where I don't even know what disjunct I would add to it, I'm not seeing how that's going to help me. So it looks like I'm going to have to use some replacement rules. So what replacement rules can I use? Well, I'm looking through this. I'm not going to use double negation. I'm not going to use these because I'm conditionals, right? So it looks like all I can use is transposition, material implication, I don't think I can use equivalence. I can use exportation. So those, I'm only limited to exportation, material equivalent or implication, and transposition. Yeah, those are the only ones I can use. So I'm going to look at this again, and it's two conditionals. And hey, look, exportation, I have two conditionals here. So I'm just going to do that and see what happens. So with exportation, I end up doing P, and I'm just going to use the and sign because I want to go find the dot sign. P and B, therefore not, or then not P. So I have conditionals here, if P, then if Q, then R. And I take those first two antecedents and I put them together as a conjunction. And then I can maintain the main operator as a horseshoe. And then I have that last consequent is the main consequent now. So that's what I've done. So P and B, they're then not P. So I'm still like, what can I really do here? So I can't do exportation anymore, but I still have like my main operator is a conditional, but I don't have this antecedent. I don't have this negated consequent. So I can't really do anything yet. Still with my implication rules. What else can I do? I could do material implication. So I could do not P and B or not P. All right, so material implication is antecedent gets negated, consequent stays the same. So I could negate this antecedent and keep this consequent, but turn this conditional into a disjunction. I mean, I could do that, but what else can I do? I can do transposition. So that's flipping them and putting a negation on. And that's what I'm going to do. I'm going to flip them and put a negation on. So what I end up getting is not P, then not P and B. So I flip my antecedent, flip my consequent, and I added negations to both. Now this is an important, oh look, I haven't even been putting my lines. So it's 1, and I did exportation, and now I did 2, and I did trans. So again, with the replacement rules, you have to cite a line, you have to cite your justification, you have to cite what rule you're using. So that's what I did there. I made that mistake, but I fixed it. Now, this is what I'm talking about when I say that you can apply these to parts of a line, right? So far, we've been applying it to the whole line. So we've been using them like we have been using the implication rules. But I have this ugly not P, and I don't need that double negation. So what I'm going to end up doing is applying double negation to only part of the line. I'm applying it to only the antecedent. And you cannot do this with implication rules. You can only do this with replacement rules. So I can get P, then not P and B, and that's 3 double negation. So I did the double negation on the antecedent. I didn't do it to the whole line because doing it to the whole line would be doing it to this conditional. And this is perfectly valid with the replacement rules. Why? Because not P has the exact same truth table as P. So just replacing that for this is not making any kind of invalid inference. Remember with this other example, here, was it this one? Or let's talk about this one. This one, when I first started, I was like, well, I need that not R, so can't I like get this S and do modus ponens on 2 and 4 to get not R? I couldn't do that, right? Because it could have been the case that Q is true and not R is false, and that disjunction would still be true. And I didn't know whether not R was the true disjunct or Q was the disjunct. So even though I had the S and I could do modus ponens on it, I couldn't just do if S, then Q or R, S, therefore not R. I could not do that. I had to pull the entire disjunct out and then do a few more steps before I can derive that not R. Because if I had just derived the not R, I'd be making an invalid inference because it could have been the case that Q is true and not R is false. I didn't have enough information yet to derive not R. Here, the difference is that not P and P have the exact same truth table. They are logically equivalent. So I could just replace it with my replacement rule, double negation, and it's totally valid. So now it's cleaner this way, and I'm able to reason about it more. And I'm thinking, hey, look, I'm getting closer to my conclusion. So I need a conditional with a P starting with my antecedent, and I have that. My consequent is not where I need it to be, but I'm starting to think that maybe I'll be able to get to that consequent with just a few extra steps. Okay. So I have this ugly negated conjunction, and when you have a negated conjunction, you can't do any rules with it or anything. We don't have any negation rules other than double negation, and that's a replacement rule. It's not even an implication rule. So what can we do? What can we do? Here's another instance of applying a replacement rule to part of a line. When I have a negated conjunction, I immediately use De Morgan, and that's why I said last week De Morgan is so important, because now what I'm going to do, I'm going to put parentheses because I want to make sure that it stays my consequent. I don't want it to get blended in with my antecedent. So I want it to stay as my consequent. So I'm going to put this condition or this parenthesis, and I'm going to get not P or not B, and that's for De Morgan. So I've applied De Morgan to only part of the line, and that is the consequence of 4. And I had a negated conjunction, and with De Morgan, you can distribute that negation to the conjuncts so long as you flip the conjunct into a disjunct. So now I have disjunction with 2 negations from a negated conjunction. Okay. So now I'm getting a little bit closer, right? So I have the not B I've been looking for, but I still have this not P here, and I don't want that not P. I want it to be if P, then not P. So I have to figure out a way to get rid of that not P in my consequent, and the disjunction too. So what can I do? Well, I want to get rid of this disjunction, but I have it as a conjunction here. So what can I do? I'm going to look at my rules. So again, I have a conditional with the disjunction again. So what can I do here? So I'm looking at the conditional stuff I have. I could do trans again, but I don't really want to, because then I'm going to negate this whole thing, and I don't want to negate that whole thing because I don't want to add a negation to it because it's kind of defeating the purpose of what I just did. What else could I do? Can't do exportation because I don't have there's no conjunction here. This is a conditional, it's a disjunction, so I can't do exportation. So, you know, you just gotta think through the finite number of rules that you have and see which one's gonna work out the best. So I think I'm gonna try material implication. So I have this conditional, and I'm gonna just change that antecedent into a disjunction, or negate the antecedent and then change the conditional into a disjunction. So I get not P, so because my antecedent is P, so I negate the antecedent. I do or not P or not B, because the consequence stays the same. Now, okay, I hope you're starting to see it's getting a little clearer now. So that's 5 implications. Okay, so I'm getting a little bit closer here. I see that I have a whole line of disjunctions, right? So I know I can mess around with these parentheses because they're all disjunctions. So the order of, if you have an entire line of disjunctions, the order isn't going to matter. I also see that I have not P, and then I have over here not P. So I have 2 not P's in there. So I want to get rid of one of those not P's. But right now, this not P is attached to this not B, and this not P is on its own. So I'm going to first put those two not P's together. And what rule is that? It's association. So if you remember, association is you got P or Q and R, P or, and then in parentheses Q or R, and you can just move that parentheses over to get P or Q or R. And that's exactly what I've done. I had P or in parentheses, not P or not B. So now I get not P or not B in parentheses or not B where it's on its own. And now I said, like, when are you ever going to use tautology? This is the case when you can use tautology. And in this case, again, we're applying it to only part of the line. So we get not P or not B. And that's tautology on 7. And I see it right away, but you probably don't. We can use one more instance of implication to get our conclusion. So again, implication over here is if P then Q, we get not P or Q, so that the second disjunct stays the same as this consequence. The antecedent changes into a negation when it's in the disjunction. So I have a negated not P or not B. So I'm going to end up getting P. So I'm going to drop that negation from that first disjunction, change the disjunction to a conditional, and that second disjunct stays the same and it becomes my consequent. And what do you know? That is my conclusion. So this problem, it's entirely from replacement rules, and it was a matter of just looking at the rules and looking at which ones I even had available to me and then just trying some out to see how they worked out. So the replacement rules are a little bit less intuitive as the implication rules, because implication rules are their implications that you can see how they're valid. These, you might not be able to see how they're equivalent unless you have done the truth tables for them, unless you have really mastered what a disjunction, conjunction, conditional, what those truth functional values are in the truth table.